Download this code from codegive.com, link in the description below. Detecting errors in your game is a crucial part of the development process. It can help you identify bugs, improve performance, and enhance the overall user experience. In this tutorial, we'll explore various techniques and strategies for detecting errors in your game, along with code examples. 1. Use logging. One of the simplest and most effective ways to detect errors is to implement logging throughout your code. Logging can provide insights into the game's state at various points in time, which can be invaluable for debugging. Example in Python ***. Python. Import logging. Configure logging. Logging.basicconfig, level equals logging.debug, format equals %, asctime, s, %, level name, s, %, message, s. Def update _player _position, player, new _position. Try. Logging.debug, f updating position for player.id to new _position. Some logic to update position. If new _position.x0 or new _position.y0. Raise value error, invalid position, coordinates cannot be negative. Player.position equals new _position. Logging.info, f player.id move to player.position. Accept exception as e. Logging.error, f error updating position for player.id, e. Example usage. Class player. Def _init_, self, id, position. Self.id equals id. Self.position equals position. Player equals player, 1, 0, 0. Update _player _position, player, -1, 5, this will log an error. 2. Use assertions. Assertions are a way to test assumptions in your code. If an assertion fails, it raises an error, which can help you catch bugs early in the development process. Example in Python ***. Python. Def calculate _damage, base _damage, multiplier. Assert base _damage equals 0, base damage must be non-negative. Assert multiplier equals 0, multiplier must be non-negative. Return base _damage * multiplier. Example usage. Try. Damage equals calculate _damage, 10, -1, this will raise an assertion error. Accept assertion error as e. Print, f error, e. 3. Implement error handling. Using try, accept, and finally statements can help you gracefully handle errors and improve the user experience. Example in Python ***. Python. Def load _game, file _path. Try. With open, file _path, r, as file. Game _data equals file.read. Process game data. Return game _data. Accept file not found error. Print, f error, the file _path was not found. Accept exception as e. Print, f an unexpected error occurred, e. Example usage. Load _game, non-existent _file.txt, this will catch the file not found error. 4. Unit testing. Unit testing allows you to test small parts of your code in isolation. This can help you ensure that individual components work as expected and can help catch errors early. Example using unitest in Python ***. Python. Import unitest. Def add, a, b. Return a plus b. Class test math operations, unitest.testCase. def test underscore addition, self. Self.assert equal, add, 2, 3, 5. Self.assert equal, add, -1, 1, 0. Self.assert equal, add, 0, 0, 0. Self.assert not equal, add, 2, 2, 5. If underscore underscore name underscore underscore equals equals underscore underscore main underscore underscore. Unitus.main. 5. Performance profiling. Performance issues can sometimes be mistaken for errors. Profiling your code can help you identify bottlenecks and optimize performance. Example using C profile in Python **. Python. Import C profile. Def game underscore loop. Simulate game loop work. For underscore in range, 1 million. Pass. Profile the game loop. C profile.run, game underscore loop. Conclusion. Error detection is a vital part of game development. By using logging, assertions, error handling, unit testing, and performance profiling, you can effectively identify and resolve issues in your game. Remember that catching errors early can save you time and effort later in the development process. Feel free to adapt these techniques to the programming language and game engine you are using. Detecting errors in your game is a crucial part of game development, as it ensures that your game runs smoothly and provides a good experience for players. In this tutorial, we'll explore common methods for detecting errors in games, focusing on code examples primarily in C, a common language for game development, especially with Unity. 1. Understanding types of errors. Errors in games can generally be categorized into 3 types. 1. Compile time errors, errors that occur when you try to compile your code. These are syntax errors that the compiler can catch. 2. Runtime errors, errors that occur while the game is running. These can be due to logic errors, null references, division by zero, etc. 3. Logic errors, errors where the code runs but produces incorrect results due to faulty logic. 2. Using debugging tools. Most game engines, like Unity, provide built-in debugging tools. You can set breakpoints, step through code, and inspect variables. Example, using debug.log in Unity. Sharp. Void update. / example of using debug.log for debugging. If player health equals 0. Debug.log, player is dead. 3. Exception handling. Using try-catch blocks can help you gracefully handle runtime errors. Example. Sharp. Void load level, string level name. Try. Scene manager.load scene, level name. Catch, exception X. Debug.log error, failed to load level, plus level name plus EX message. 4. Assertions. Assertions can be used to catch logic errors by ensuring certain conditions are true during development. Example. Sharp. Void update. Debug.assert, player health equals 0, player health should never be negative. 5. Logging. Implement comprehensive logging throughout your game to track the flow and state of your application. Example. Sharp. Void collect item, item. If item equals null. Debug.log warning, collected item is null. Return. Debug.log, item collected, plus item.name. / additional logic. 6. Unit testing. Write unit tests for your game logic to ensure that methods behave as expected. Example with NUnit, C# test. Public void test player health reduction. Player equals new player. Player.take damage, 10. Assert.err equal, 90, player.health, player health should be reduced by 10. 7. Profiling. Use profiling tools to analyze the performance of your game and detect bottlenecks and potential errors. Example, Unity Profiler. Open the Profiler window in Unity. Monitor CPU and GPU usage, memory allocation, and frame rate. Identify spikes or unusual behavior during gameplay. 8. Feedback from playtesting. Encourage playtesting to gather feedback from users. Sometimes issues may not be evident until others play your game. Conclusion. Detecting errors in your game involves a combination of using debugging tools, implementing error handling, writing tests, and continuous playtesting. By following these practices, you can identify and fix issues, leading to a more polished and stable game. Remember, the goal is not just to find errors but to create a more enjoyable experience for your players. Happy coding!